VLSos here. This is a video lesson on linear inequalities, graphing them. Linear is a fancy word for line, or something that looks like a line. An inequality uses the comparison symbol less than, greater than, less than equal to, or greater than equal to. So what we mean by a linear inequality is something like this. Y is less than 2x minus 3. This is an inequality because the comparison symbol is one of the inequality symbols, in this case less than. If this were an equation, that was an equal sign, then we would graph something like this on a two-variable axis, x and y, and we would plot points, connect those points, and the graph would be a line. So this is linear since the graph of this kind of equation looks like a line. It's an inequality, so we have a little bit more to pay attention to than an equation. We have a process that starts with step number 1. Make sure it's solved for y. Step number 1 is finished. Our inequality has y alone and positive on one side. So we can go to step 2. Use a t-table and treat it like an equation. So we're going to make a t-table to organize points for graphing with a column for x and a column for y. We're going to treat it like an equation, which means that we're going to choose some values of x. In this case, -2, 0, 1, and 2 are good values of x to work with. And we're going to find the value of y that corresponds to our choice by substituting in our value of x and solving for y. We're going to ignore for the moment that it's an inequality, and we'll take steps later to address that this is a less than comparison. With my choice of 0 for x, because 0 is a very easy value to use, I'm going to find y by substituting 0 in and thinking of this as y is equal to 2 times my choice of 0 minus 3. Or 2 times 0 is 0, and then minus 3 is -3. Working with an x value of 1, I substitute it in. Y will be equal to 2 times 1 minus 3. 2 times 1 is 1. And then if I subtract 3, I get -1. Substituting in the value 2, y is going to be equal to 2 times 2 minus 3. 2 times 2 is 4, and then minus 3 is +1. I've saved the negative number for last. Substituting -2 in for x, I get y is equal to 2 times -2 minus 3. 2 times -2 is -4, and then if I subtract 3, I get -7. These are coordinates that can be plotted on an x and y axis. There are two variables in this inequality, so I need two axes. The x-axis is typically horizontal, y vertical. I need to label a tick mark on x at -2, and I'm going to put y1 is there. Plotting the point -2, -7, that's -2x, and then -7 puts that point down here. Plotting the point 0, -3, that's 0 on the x-axis, -3 on the y-axis is here. Plotting the point 1x, -1y, and 2x, +1y. That was step 2, using a t-table and treating it like an equation to plot these points. But now I need to consider that I'm graphing an inequality. Step 3, we could say, was plot the points from the t-table, which has already been done. Now I need to connect the points. But I need to consider the sign. I'm going to connect them with a solid line for the inequalities greater than and equal to, less than equal to. And for symbols less than or greater than, I'm going to use a dotted line. A solid line signifies that we can be at that place on the graph, that the values of x and y can be exactly equal to that place that is solid. A dotted line is like a boundary, but we can't have values on the line. A dotted line represents a location that we can approach, but we can't be at. We use a dotted line for less than. So these points that I've plotted, treating it like an equation, I now must connect with a dotted line. It's a boundary, but I can't be on it. A solid line represents a boundary that I can be on, or those values that are represented on the line can be used as solutions to the inequality. We have one more step to take to finish up. We need to shade. To show the region of all possible solutions, we either shade above the boundary line or up for the symbols greater than or equal to or strictly greater than, or we shade below the boundary line or down for inequality symbols that are less than equal to or strictly less than. This ought to be intuitive. If we have the equation y is less than 2x minus 3, and the line represents those values that can be equal to 2x minus 3, then to show the solutions that are less, we need to shade below the line, those values that are below because they are less than the boundary. This can be a sophisticated process to graph linear inequalities. Follow these steps and you'll do well.